I'm ready. All right. First question says, and I need this guy up so we can do that. All right, is everybody with me? All right, you were a little rusty since Thursday was a little while ago, a little rusty getting going, but this is a question where you've got to be paying attention because I threw it all at you in one question. I gave you a salt, not just a straightforward weak acid or weak base. I gave you a salt that you have to say, okay, let me find a piece of the salt that is either acidic or basic. I'm not going to give you a salt that's both. I'll give you a salt that's either acidic or basic, especially when I give you a problem like this, because if it were neutral, the whole thing, you can't do anything with it. He doesn't do anything. He floats around in the water. The pH of the water doesn't change. All right, so this question says, what is the pH of a 2 molar KC2H3O2 solution if the Ka of acetic acid is 1.8 times 10 to the minus 5? Write the formulas of the conjugate acid-base pair. We've got to keep practicing that, even though the OWL really had you do a good job of recognizing those. And if you did your OWL, then you were a little bit up to speed on that. First things first, you've got a salt that's got these two things. And you've got to ask yourself, what part of my salt is acting as an acid or acting as a base? And you've got to look at this cation and say, that's one of my 6 neutral guys. He does nothing, right? And then you got to look here and say, he's not one of my 6 neutral anions, so he must be basic, because there's only 2 exceptions to that. And when we come across them, I'll point them out. So since he's basic, if he sits in water, you got to do the proof of him being basic. So when he sits in water, what does he do to the water, Jordan? He takes a hydrogen, creating his conjugate, which you can either put the hydrogen on the outside, on the end or on the beginning. The way I've written it is more the inorganic way, so I tend to write it on the front, because the other way it would be CH3COOH is the other way that he's written when he's on the end. And then that leaves OH minus behind. I have no ions floating around. With my original 2 molar potassium acetate gives me 2 molar potassium ion and 2 molar acetate ion. Agreed? Okay? So then you have your minus X, your plus X, and your plus X. So you say X, X. Everybody watch. You have to down here say this before you can say this. Yes? AP exam is looking for you to show them. You know it's this, but you're choosing to write it down like that. Okay. Now, I can solve for X if I have the KB. I don't have the KB, but I have his conjugates, Ka. So that means I go back up here to what I should have stored away in the brain, and that is Ka times Kb will always be Kw, which is always this constant, never changes. And so when I say the Ka underneath the Kw, I get a value of 5.6 times 10 to the minus 10 for my Kb. Yes? Now I'm ready. Now I'm ready to say my Kb expression for this reaction is HC2H3O2 times OH minus over C2H3O2 minus. And now I'm ready to plug in all my numbers. 5.6 times 10 to the minus 10 is my Kb. That's going to equal x squared over 2. X comes out to be 3 times 10 to the minus 5. And I know there's some decimal places there. 3 point something something times 10 to the minus 5. Yes? Okay, Kyle, what was that something something 3 point what? 1623. So I'll just write it as 3.16 times 10 to the minus 5 molar. Kelsey, very important. Who is X? Because X is not always the same substance. But in this particular case, who is X that is most important? OH, did you hear that? Because we have a base we have a basic salt. My X from the ice chart is OH. Sometimes my X is H plus or H3O plus. And sometimes my X is OH minus. Is it important for me to pay attention who X is? Yes, it is. Because when I now go up here and say minus log of 3.16 times 10 to the minus 5, I am obtaining, Austin, the who. The who. The POH, not the pH. The POH. Very important that I recognize that. And so that number came out to be like, what, 4.50 about? Something along those lines. And so when I say 14 minus 4.50, I end up getting something like 9.50 for my pH, which is ultimately what I was looking for, yes? See, if you have a base and you minus log that OH and immediately call it pH, you should stop and say, wait a minute. Bases do not have pHs less than 7. I did something, right? You got to always be thinking, because I threw everything at you with this number one that I could to trip you up. Why? The AP exam well, to see, are you paying attention to the details? Because if you don't, it's not going to be pretty. Are you paying attention to the details? And the details are, I have a salt, I have a basic salt, I need the KB, not the Ka. When I minus log X, I'm going to be getting POH, not pH. That's what I mean by giving you all the little tricks in one problem. Okay, so the second problem has exactly the same kind of tricks, agreed? Okay, so when I bring him down a little bit so I can see him a little bit better, that guy, we have, what is the pH of a 1.5 molar NaF if the hydrofluoric acid's Ka is 6.9 times 10 to the minus 4? Write the formulas of the conjugate acid base pair, which I didn't do up top. I'll do in just a minute. All right, first things first, NaF breaks up into Na plus and F minus. I analyze those and say he's neutral, so he does nothing. I analyze that and say he's not one of my 6 anions, it's neutral, therefore he has to be basic, because there's only 2 exceptions to that. I prove that he's basic because when he sits in water and he's basic, he makes hydroxide and his conjugate acid. All right, so here's the conjugate acid, here's the weak base. Weak base is conjugate acid. The pairs, we have 1.5, we have 0, 0. We have minus X plus X plus X. 1.5 minus X is an approximate 1.5. X, X. I need the KB, so I take KW and divide it by KA. 1 times 10 to the minus 14 divided by 6.9 times 10 to the minus 4. And I get a value of something times 10 to the minus 11. 1.449. Ten to the minus 11. That's not as good as the Ka, is it? Ka was much better than the Kb. We're going to talk about that in just a little bit. Okay, so now what I do is I say Kb, which is equal to HF times hydroxide over F minus, is going to now need numbers. 1.45 times 10 to the minus 11 equals X squared over 1.5. And when I get X, I have gotten the amount of hydroxide. Larissa, did you get X? No. Hayden, did you get X yet on number 2?
Yeah, I got it.
Okay. Kelsey, did you get X yet? 4.66 times 10 to the minus 6 molar. So when you minus log that, Kelsey, what did you get? 5.3. So the POH is 5.3. 5.3 something. 5.33. I still would need another something to give me 3 sig figs because remember those decimal places. All right. And so then I say 14 minus 5.331. Is that what you said? It's not, because the number in the front of the decimals doesn't count in PHs and POHs only. It's only decimal numbers. All right, so 5.33 is going to give me an answer for my pH then to be about 8.67. And I still need another guy right here, but that's okay. Okay. See how that works? Okay. Did anybody get to number 3? Only a couple of you. Okay. Question number 3. I'm not going to work the whole thing out. I just want to show you question number 3. I'm going to stop this for a moment. Stop for Skylar's sake. Stop. And the other day I discovered somebody had messed